Hey guys, Mr. Moscato with you. Hope you guys are enjoying the snow day. All right, it's a beautiful day outside. It is bright and sunny. So, like I said, right, the day without algebra is like a day without sunshine. Well, today we have both, right? We have a bright sunny day outside, and we have a little bit of algebra. So it's the kind of the best of both worlds here. All right, so today what we're going to do is we're going to take a look at chapter 3-6, proportional and non-proportional relationships. All right, so believe it or not, we have already discussed proportional relationships. A proportional relationship is exactly the same thing as a direct variation. So remember a couple of lessons ago, all right, we talked about uh, equations that were direct variation. And if you remember the form of an equation that is a direct variation, it was y equals k times x, where k is some constant value, all right, and x is our input and y is our output, right? So when we take a look at this direct variation, uh, right, direct variation equation, right, or the form of a direct variation equation, all right, we automatically know a couple of things about it. Number one, all right, if x is 0, what is y? Well, 0 times any value is going to be 0, which means that y is going to be 0. So remember that one of the definitions of direct variation is that the line will pass through 0, comma 0. That's one of the rules of direct variation. All right. And the other thing that we know about direct variation is that it is a linear function. And it's a linear equation. Why? Because we can write it in standard form. Okay, so what would this look like in standard form? All right, so remember when we put something in standard form, we have the x's and the y's basically on the same side of the equal sign. Okay, so if I subtract y over here, right, I would get something like, right, so subtract y, I would get 0 equals k times x minus y. This is standard form, all right? So even though I have a 0 over here, that's okay, all right? I can write this equation in standard form, which means that it is describing a line, right? So this is a line. All right, so that was direct variation. Proportional equations, all right, or proportional relationships are basically follow the exact same rules. Okay, they have to be direct variation. All right, they have to be in the form direct variation, which means that a proportional relationship describes a line that passes through 0, 0, all right, on the coordinate grid. All right, so let's figure this out, right? So when we talk about proportional relationships, we are basically talking about real world situations. Okay? When we discuss direct variation, it is a mathematical concept. All right? One describes the other, though. All right? So if we're talking in real world terms, we say, yes, that relationship is proportional. If we're talking in mathematical terms, we say, yes, that is a direct variation. All right? But for our purposes, right, they're the same thing. They describe the same thing. So let's take a look at a proportional relationship. All right, so proportional relationship. Let's say that I am a very consistent free throw shooter, okay? And I'm going to make 8 out of every 10 free throws. So it doesn't matter, how I make them. It doesn't matter how many I shoot. If I shoot 10, I'm always going to make 8 and I'm going to miss 2. Okay? If I shoot 20, I'm always going to make 16 and miss 4. All right? That's just the way it is. I'm not a great free throw shooter, although 80% isn't bad. All right? However, I am very, very consistent. All right? So, we have a couple of questions based on my free throw shooting abilities. All right? What is the equation which shows the number of free throws attempted versus the number of free throws made? All right, so let's talk about that first. And then second, we're going to graph that equation. What would that picture look like of that line? Okay, and then we'll determine, is this a proportional relationship? All right, so we have free throws attempted, we're going to represent as A, and the number of free throws made, we're going to represent as M. Okay, my input is my A. How many free throws am I attempting? All right, that is my input. All right, because I can't have any made until I have attempted some. All right, so what we're going to do is we're going to say, all right, so M equals, okay, and then, well, what is my rate? Okay, so what is my constant rate of free throw shooting? Okay, so remember, this all goes back to slope. It all goes back to that constant difference. Okay, all of these things are exactly the same thing. They just describe different situations. We use different words to describe different situations, but it's all relating to some kind of a linear function where we're describing lines. Okay, so M equals what? Well, if I'm making 8 out of 10 free throws, right, that is my rate of change. 8 out of 10, all right, times what? Times how many free throws I attempt. All right, so 8 out of 10 times A. Okay, that's it. Now we can simplify this a little bit, and we can simplify that rate of change from 8 over 10 to 4/5. Okay, so M equals, right, 4/5 times A. Okay, that is our proportional relationship. All right, so let's graph some points. All right, let's see what this equation looks like in terms of a line. All right, so we'll start, right, well, let's make a little table. All right, so if I have A is my attempts, and I have M is my free throws made, all right, so let's see what that would look like. All right, so if I attempt 10 free throws, okay, let's start with 0 actually. Okay, if I attempt 0 free throws, right, how many would I have made? All right, well, 4/5 times 0 is just 0, right? So if I haven't attempted any free throws, I haven't made any free throws. All right, so our first point is going to be 0, 0. Okay, let's say that I've shot 10 free throws. All right, so according to our equation, if I've attempted 10 free throws, then I'm going to have made 8. Okay, good so far. If I have shot 20 free throws, all right, well, I'm going to make 8 more, right? So 8 plus 8 is 16, right? So we have a constant rate of change here, right? Plus 8, and on, right? So if I shoot 30 free throws, all right, I'm going to make 24 because, again, I am the world's most consistent free throw shooter. Not the best free throw shooter, but the most consistent free throw shooter. All right. So we have enough information here to start to graph our line, right? What does the picture look like? All right. So remember that here A is the attempts. Okay. M is the free throws made. All right. So I'm going to start to plot my points. So my first point is at 0, 0. Okay. So remember that we're plotting in terms of A, M, input, right, versus output. Okay, so it doesn't matter if we use x's or y's. It doesn't matter if we use f of x and x or x and f of x, right? Whatever the letters that we use, whatever we're calling these things, all right, that's how we're going to describe our point pairs. The first value in that parentheses, that first coordinate is always going to be the input, and the second value is always going to be the output. All right, so if I have a point at 0, 0, so I have one here right at the origin. Okay, if I shoot 10, I'm going to make 8, so that's going to be right around there, let's say. If I shoot 20, I'm going to make 16, so that's going to be right about here. All right. If I shoot 30, I'm going to make 24. So that's going to be where? That's going to be 30 and 24, right about there. All right, and so on and so forth. All right. So at this point, I can go ahead and draw my line. All right. Let me get my straight edge here. And I'm going to, let me select another color for the line. All right. And let me move my coffee cup out of the way. And all right, so we're going to have a line that looks kind of like that. Okay, there we go. All right, so this is the line that describes, okay, M equals, right, 4/5, which is my rate, times A. Okay, that's it. That's a proportional relationship. It's a direct variation, all right, because it follows all of the rules, all right, for direct variation and proportional relationships. It passes through 0, 0, and there is a constant rate of change. It describes a line, all right, because there is a constant rate of change, all right, a constant difference, all right, between my points. All right, terrific. All right, proportional relationships, very simple. All right, so let's take a look at a linear function that is not a proportional relationship. Okay, so we can have linear functions that are not proportional relationships. All right, so let's say that we have a piggy bank. All right, so grandma gave me a piggy bank. All right, and because grandma loves me, she stuffed $5 into my piggy bank when she gave it to me. Okay, then every week, right, being the dutiful grandson that I am, I promised grandma that I would put $10 in that piggy bank. All right. What I want to do is I want to describe the contents of that piggy bank for any given week. Okay. So what is the equation that describes the contents of my piggy bank after W weeks, right? So W is going to be my input in terms of my function. All right. And then Y, how much money I have, is going to be my output. Okay. So what does this start as? Okay. Well, we're going to graph the equation. We're going to create the equation. Let's create a table first, however, just to see what those values might be, right? Because this is pretty simple to create a table of values, right? So W, let's say that W is here. Okay, let's actually raise it up a little bit. All right, so let's put it our table here, right? So W is here. W is the number of weeks. All right, and then Y, all right, is the number of dollars that I have. All right, and I'll put a little dollar there. All right, so Y dollars. All right, there. All right. So after 0 weeks, right, how much money is in that piggy bank? Well, grandma gave me the piggy bank with $5 in it. Okay, so as soon as I got the bank after 0 weeks, right, there were $5 in the piggy bank. Okay, now a week passes by, right, and I put $10 in that piggy bank. So after 1 week, I'm going to have 5 plus $10 is 15. All right. After the second week, I'm going to put another $10 in. Okay, so that's going to be 15 plus 10 is going to be 25. All right, and then after 3 weeks, I'm going to have 35, and so on and so forth. All right, so that's enough information there. All right, to start to figure out my graph. All right, so let's plot these points, and then we'll work backwards and actually figure out the equation. We could have figured out the equation first, figured out the table second, figured out the graph third. All right, but we have a table, so we have some points here. All right, so remember here that what we're going to do is we're going to plot our points as our input is the number of weeks. All right, so W. All right, and then the output is going to be Y. Okay, so our first point is going to be at 0, 5, which is going to be here. Okay, our next point is after 1 week, it's going to be 1, 15. So after 1, I have $15. So I'm going to have a point there. After 2 weeks, I'm going to have $25. So I'm going to have a point here. All right, and then after 3 weeks, I'm going to have $35. So I'm going to have a point here. I'm going to get my straight edge here and draw my line. Okay, so it's going to look something like that. Okay. All right, and this line describes the equation. Now, we haven't come up with the equation yet, but you can see right now. So even though I have a constant rate of change between my points, between my values, right? Every value, right? So every value increases by plus 10, right? As I move down the line, this is not direct variation. It is not a proportional relationship because at week 0, I have $5, okay? And the definition of a proportional relationship is the same as that of direct variation, which is that the point must pass, all right, or the line must pass through 0, comma 0, okay? And it must be a line. So even though this is a line, it does not pass through 0, comma 0. So this is non-proportional. All right, so let's figure out our equation, okay? All right, so we said that y is the number of dollars that we have in the piggy bank after any given week, okay? And we're trying to figure out the equation here, right? So the slope of the line is plus 10, right? That is the constant difference, all right, between values. Okay, that's the slope is plus 10. So anytime that we're drawing a line, we have the slope times the input. Okay, so our slope is 10. Our constant change, right, our constant value is 10, all right, times the input, right? So the input in this case is W, okay? All right, but it's 10 times W, but then it's going to be plus something, right? So it's going to be plus, right, the initial value of our line. So at weeks equals 0, right? When we first got the piggy bank, we had $5. Well, everything after that, we're going to start at $5, right? So that is our y-intercept, all right, is positive 5, okay? Our initial value is going to be positive 5, right? So what we're going to do is our equation then is going to be the amount of money in our piggy bank equals 10 times the number of weeks plus 5. All right? Real simple. All right? So if you think about it, right? So after 4 weeks, I have put in a total of $40, right? $10 per week times 4 is 40, but I have $45 in my bank. Okay? So obviously where's that extra $5? All right, that was my initial value. All right. So that's the difference between a proportional and a non-proportional relationship. All right. So a proportional relationship describes a line that passes through 0, comma 0. All right. It is a direct variation. All right. And then a non-proportional relationship, all right, is basically or can be a line, all right, that does not pass through 0, 0. Right. So all direct variation equations are proportional relationships. All right. All proportional relationships are lines that pass through 0, 0. Okay, but not all lines have to pass through 0, 0, in which case they are non-proportional relationships. All right, so that's it for today in terms of this topic. All right, pretty straightforward. I have left some work for you guys on Blackboard, so make sure that you take a look at that. Get all that stuff finished over the weekend, and I hope you guys enjoy the rest of your day. Enjoy the nice weather right now. It's a little chilly, but it's actually pretty nice outside, so enjoy that. And hope you guys have a great weekend, and we'll see you on Monday. All right, this is Mr. Mascaro. Have a great day. Bye.